Let's dive in here to part 2. All right, there we go. Theater has 20 rows, 28 seats in the first row, 33 in the second row, 38 in the third row, and so forth. How many seats are in the theater? Look at these formulas I got for you up here. This will be exactly what you see at the top of your part 1 and part 2 tomorrow and the next day. Some of these we didn't even use. I do different versions in other semesters. I don't think we even used this, and you won't need to. Yeah. Is that right? Yeah. Yep, that's right. Anyway, the rest of them are ones we used. So anyway, go ahead. See what you can do. Let me give you that. You'll get more out of this than if I just whip them out one after another, but I can't give you too much time. See what you can do with 1 minute. Do something good. This is our last exam. Final is week after next, right? On Wednesday, 17th. The final exam will replace your lowest score. Don't let it be this one. Do good on this one, so your final exam can replace one of your other lowest scores. It's going to replace the lowest among the 4 scores. So if you do good on this one, then the final could replace one of your other ones. So, all right. So they want us to go 20. Where's my pen? It's not working. Oh. No, I got to charge my pen. Everybody got that written down? Real quick, I'm going to charge my pen for about 1 minute here. Didn't realize my pen was dead. Oh, yeah. So 28 plus 33 plus 38 plus ... right? And there's 20 rows altogether, right? Isn't that what they're saying? So 28 seats in the first row, then 33, then 38, 20 rows altogether, right? We're supposed to add all those up. That's what they're saying, to get the total number of seats. So is that an arithmetic or geometric? So now's the trick. They're both together. That's why you must spend time on the practice exam, right? Even if you did great on the homework or really understood it in lecture, I was only doing one topic at a time. That's different than a test. Don't fool yourself, right? On the test, they're all mixed up. And you've got to be able to distinguish arithmetic from geometric, which formula to grab, right? That's, that's why you want it. You've got to. You're crazy if you don't spend time on the practice exam. So arithmetic or geometric? Arithmetic, because it's adding 5 every time, isn't it? It's adding. When you're adding the same number every time, you're arithmetic. If you're multiplying the same number every time, you're geometric, right? So it's adding 5, so it's arithmetic. Okay. Now, so now notice these two are arithmetic. Arithmetic. And then here's the a sub n and s sub n and s sub infinity for the geometric. All these 3 here are geometric, and here's the a sub n and s sub n for arithmetic. So notice how we have an a sub n and s sub n for arithmetic, and an a sub n, s sub n, and s sub infinity for geometry. And they go in order: arithmetic first, then geometry. They'll be just like that, exactly like that on your exam. So, do I want to use the a sub n arithmetic or the s sub n arithmetic? I'm going to use one of the arithmetic, right? I know it's arithmetic. How do you know which one? Well, yeah, I know eventually, but what's the main one? What's the main one? The main one is s sub n, because we're adding them. Sum. We're adding them. Add. They want to know what they all add up to be, sum up to be, right? Use s sub n mainly. We might use the other one secondarily, but the answer is going to come out of the s sub n one, right? Because we're summing them. Use the s sub n because it's a sum, right? If these were just commas in between, maybe that would help if I clarify. If they were just commas and they said, hey, what's the 20th term or what's the 37th term? That would be an a sub n question. They don't want me to add them in that case. They would just want one of them in particular. But no, they're wanting me to add these things, sum them. What do they add up to be? That's an s sub n question. See the difference? All right, so we determined arithmetic and s sub n. So let's write down the formula that we've now decided is the one. N over 2a1 plus an. remember what those parts are. This is the first term, last term. What is n? Number of terms, right? N is, in all these formulas, n is the number of terms, a sub 1 is the first term, a sub n is the last term. So, here we go. Number of terms over 2. So what's the number of terms? N goes up here. What's the number of terms? 20. There's 20 rows, right? Every one of these rows is a number. 20 rows, right? That's the number of terms, the number of numbers, right? 20. N is 20. What's the first term? A1. Well, 28. What's the last one? I don't know. So now I can say, okay, I don't know a sub n. So then also use a sub n formula, which is what? Go back up here. There it is right there. It's a1 plus n minus 1d. Does that make sense? I'll use the a sub n formula secondarily. Get the answer for a sub n and plug it right in here, because a sub n is going to go right there, huh? Does that make sense on that? So, all right, so let's finish getting a sub n. What is it? It is a1. What's a1? 28 still. Plus n minus 1. N is still 20. Times d. What's the d? D is the difference from term to term, the jump, 5. Huh? Does that make sense? So I can find a sub n. It is 28 plus 19. Am I on the screen? Good. Times 5. I'm getting a little scribbly there. 28 plus 19 times 5. Are we good? Are we happy with that? Is that making sense? I can't write it. And then that's somebody had that on their calculator? 123. 123, thank you. So 123, put it right here, and finish it up. So the answer is still going to come out of this S sub n formula, the final answer, because that's the main thing we're doing is summing them. But we had to use the A sub n on the side. So that adds up to be what? 20 over 2 is 10, times 151, that's 1510. There it is. 1,510 seats in that theater, or whatever it was. Theater, yeah. Is that good? Does that make sense? So I write them down. I see, oh, it's we're adding them up. I need the S sub n for arithmetic, because it's adding 5 every time. Plug everything in. I need the A sub n, so use the A sub n formula for arithmetic. Get the 123, stuff it in, finish it up. 1510. No questions? We good? All right. I might sometimes on these I take different ways. On the other semesters I taught it different ways. So I don't know what I did on the key, but anyway, here's the way we did it this semester. All right, all right, problem number 2. 42nd term of the arithmetic. See if you can do that. 42nd term of the arithmetic. Let's grab the right formula first off. Don't say it out loud. Give everybody a chance. You know it's arithmetic. They're saying that. So it's one of these two. These are the two arithmetic, right? Arithmetic for these two. These 3 back here are the geometric, which we'll get to in a bit. Ask yourself, are we adding them up? No. There's just commas between them, right? So it's not S sub n, is it? It's A sub n. Everybody tracking with me? Right? A sub n. This is A sub n because they're not added. It's not S sub n. It's not a sum. That's what all the S's stand for in all these formulas, is sum. It's not a sum. They're not adding these numbers up and they want to know the total. They're just listing them, with commas. Good? All right. So what's the first? A1 is first term. It's always first term. N is number of terms. And the D is the difference, right? So first term, what's first term? -5 plus N. What's the number of terms? Yeah, 42nd. Remember, the ordinals are always in. This is in. But I mean, an ordinal is a number that implies order. 42nd. It doesn't just say 42. It says 42nd. That's an ordinal. It tells the order, right? Those are always in. That's the number of terms. I'm trying to find the 42nd term. And the D, what's the D? -4. The D is the jump from term to term. From there, term to term, it goes down by 4 every time. That's the D. The difference. So there we go. So -5 plus 41 times -4. What's that? -5 minus 164 minus 169. There it is. We got it. Questions on that one? We good? Can I flash off of that? Whoops, the wrong one. There we go. All right, so perimeter of a parking lot. Find the dimensions of the lot if the length is 50 yards more than 3 times the width. That's weird. Feels like, where'd that come from? Is that something we covered? I think it's helpful to draw a little picture. You don't have to. I think it might be helpful. Maybe a smaller picture. I need room to work. See what you can do, rather than me just diving in. I guess it's longer than it is wide. Yeah, whatever. Who cares? More like that, I guess. Yeah. So, see what you can do. Perimeter is 500 yards. What's the perimeter of a rectangle? This thing is a rectangle, isn't it? It never really said that, did it? It's a bad problem. I just assumed rectangle. I bet you assumed rectangle. I think it is a rectangle. They never said it's a rectangle. Maybe it's a trapezoid. You know, they should have said rectangle. Anyway, bad problem. But anyway, it's a rectangle. Perimeter, what's the perimeter formula for a rectangle? So remember, this is the width, the length, the length. Perimeter is going around the thing, right? You march around the edge of the thing. You do the length twice and the width twice, right? 2L plus 2W, remember that formula? Put that in your 3x5 card if you need to. All right, so there's the formula. The perimeter, 500, right? It's right there. Is 2L plus 2W. Now, we got to figure out what's the L and what's the W. Well, it says 50 yards more than 3 times. So this is 50 plus 3x. This is 50 plus 3x, and this is x, and this is x. Is that okay? Right? So the length up and down is 50 more than, 50 added to 3 times the width. So the width is just x. You call it W if you want. Would that be easier? Whatever. Doesn't really matter. You might like that better. Whatever. It doesn't matter. So I could say, okay, this will be width, and the length is 50 plus 3 width. If you want. You could do it that way. Does that make sense on that? So then 2 times, what's the length? 50 plus 3W. Right, everybody see what I did there? I put in for the L 50 plus 3W. Put in for the L 50 plus 3W. Or you could have just had the 500 is 2L plus 2W, and then length is 50 plus 3W. Yeah, you could have just written those. Yeah, maybe that's better. Hang on. I'm trying to really confuse you, so I'm going to do 3 things at once. No, I'm just kidding. I'm trying to be more clear. Let me try to be helpful. This is probably the way that will make the most sense for y'all. Is just to say, okay, look, there's my first equation, right? 500 perimeter is 2L plus 2W. And the other one is, just take it this way. Rather than doing the diagram, you can just say length is L equals 50 more, 50 added, 3W. Is that better? That's probably real straight. Just real straight from the words, right? And then take this and plug it in for L right there. Because you have 2 equations, 2 letters. You can do the addition method or the plug-in substitution method. Substitution would be real easy, I think. You're going to get the same thing I had, but maybe this is a more straight ahead way to get there. Does that make sense? How I just took those two facts they said, perimeter 500, so perimeter 500, and L is, length is, 50 more, 50 added to 3W. Like that. All right, so then plug it in. So then when you do that plug-in thing, this one's going to become 500 equals 2L, but in the place of L, I'll plug in 50 plus 3W. That okay? Plus the 2W. So I just stuffed that right in there into the 2L plus 2W. The L just became 50 plus 3W. Now I've got one letter, I can solve it, right? Boom, boom. 500 is what? 100 plus 6W plus 2W. 500 is 100 plus 8W. Subtract 100. 400 is 8W divided by 8. What's that, 50? Width is 50. How do we get the length? Plug it in right there. Boom. L is 50 plus 3W. L is 50 plus 3 times 50. Am I still on the screen? Yeah. Okay. So move this out of the way here. L is, what's that, 50 plus 150. L is 200. Length is 200, width is 50. We good with that? Questions on that one? Okay. So it looks like there's going to be a two equation. I didn't remember we covered that. Two equations, two letter one? Like 11-1, like right, I think it's the oldest thing in this section. The first thing we did after the last exam. Yeah. Okay. Sequence is defined recursively. Write the first four terms. Can you do that? Write the first four terms. Give me a second. Do you know what they're wanting on this is making sense? So here, that is the first term. A1 equals 2 is the first term, right? There's the first one. How do we find A2? Does this make sense? Let me rewrite this over here and try to say it in a way that makes more sense. This says any term, you know, the nth term, that could be any term, is 3 times the previous term add 4. Do you realize that's what that's saying? I think if you get that, it'll be a very easy problem for you. Right? Because that a sub n minus 1, that means one term previous. You know, the term right before. Right? Because n minus 1 is 1 less than n, you know. So basically, it's all about being able to read this and understand that it says, you want any term? Just take 3 times the previous term and add 4. And you'll have it. So, okay. So I've got the first term here. A1 is 2. That's the first term. So then if I want the next term, what do? Take 3 times, so it's 3 times the previous term, add 4. So it's at 10? Does that make sense how I did that? It's all about what this is saying. 3 times the previous term, add 4. So they give me the first term is 2, then I just take 3 times that previous term, add 4, and then what do I do for a sub 3? Same thing, 3 times the previous term, add 4. What's the previous term? Now it's 10, huh? So it'll be 34. So A1, A2, A3. Got to do one more over here somewhere. I'll do A sub 4. What is it? 3 times the previous term. Add 4 of the previous term being 34. So 90 to 102. Is it 106? 106 on that. There's the first 4 terms. That's all they want. So they're just testing if we can read this statement here. I think it's easy once you know what that's saying, I think. Make sense how to read that? Is that okay? N minus 1, a sub n minus 1 means previous term. All right, I'll move on. Find the inverse of the matrix by hand or by graphing. Remember, you'll have your graphing calculator for this part, for all this stuff. You know, the only thing you won't have your graphing calculator for is the trig. So you'll have your graphing calculator for all this. So it's totally fine with me. You want to just put this thing in your calculator and hit the inverse button. Do you know how to do that? Do you remember how to put in a matrix? Definitely. If you don't, you know, come see me or Roberto, or hang out after class, or do whatever to learn. You know, I don't have time to go over all that again. If you missed that for some reason, or go back to the lectures when I did show some of that. I don't know, but I don't show graphic calculator on the screen. I can't run. So anyway, make sure you can, because there is some of that. So just put that in your calculator and hit the inverse button. So just use your calculator, or I'll show it by hand. Or by hand. I don't care either way. Anybody remember how to do it by hand? Anybody care about doing it by hand? What's that? So you switch these two. So 2 goes here, 5 goes here. And then you change the signs. Oops, I need a little more room. Yeah, so if you want to do it by hand, again, you don't have to at all. You would switch the main diagonal, change the signs on the other diagonal, and then divide all 4 of them by what's called the determinant. The determinant equals the main multiplied minus the other diagonal. So the determinant equals 5 times 2 minus 3 times 3. It's going to be 1, huh? 10 minus 9, 1. So divide these all by 1, nothing happens. So it's 2 minus 3 minus 3, 5. Is the answer. Is that what your calculator's told you? That is the inverse. I would just do it with my calculator probably. Just put them in, hit the button. Tim?
So when you're doing the determinant for the other part, since you have to switch the signs on B and C, do you use the B and C before or after you switch the signs?
See, it'll be the same thing though. Because if you switch both signs, they're still going to multiply to be what they were. Yeah, so it makes no difference. Everybody hear Tim's question? He's saying, when you do the determinant and you're multiplying the other two, is it like here before you made the change or after you switched them? And my answer is either one. It's going to be identical because we switched both sides. So they're still going to multiply to be whatever they did before. So no difference.
Yeah, don't you do the negative? A negative 1 instead of a positive 1. Does that make a difference?
It'll be exactly the same. So here, I'll do it. So if I did these two multiplied, 2 times 5. See, I just switched the order, so it doesn't matter there. Minus these two, which is...
I thought you meant if you multiply 3 times 3 first, and then 5 times 2.
Oh, no, you can't do that. Yeah, no. Tim, didn't you mean doing it here instead of here?
Yeah.
After
switch the signs.
Yeah, it doesn't matter. It'll come out the same either way. All right, let's go on to number 6. Find the first term in the common difference for this arithmetic sequence. 6th term is 27. 15th term is negative 63. Give you a second there. We did a bunch of these, but it's been, 3 weeks. So see what you can remember. Notice they mention arithmetic sequence. So you're going to use one of the arithmetic sequence formulas. Right? There's 2 of them. There's an A sub n and an S sub n. How do you know which one of those 2 you want to use? Well, let me ask this. Are we adding them up anywhere? Does anything on this problem number 6 here show you that we're adding these terms up? No. So we're not going to use S sub n. We're going to use A sub n for the arithmetic. Does that make sense? It's only when they're added up that you use the various S sub n formulas, the 2 different S sub n formulas. So just here's our formula that we're going to use. There's the A sub n. See if you can use that. Remember, these are the ones where you plug in twice to that formula and get 2 equations with 2 unknowns? Remember these? I'm going to go to fresh screen then and try that. Okay, so we get, again, we're going to use A sub n is A1, n minus 1d. So I'll do the first one. A sub n is, remember, A1's first term, N is number of terms, D is the difference. So, so A1, I don't know A1. Number of terms, sixth. Remember the N is always the ordinal numbers, the numbers with the TH or the RD, thirds, fifth, seventh. Those are always your N's, right? Times D, I don't know D, is 27. Is equals, huh? Is 27 equals 27. Everybody see what I did there? I just plugged in N, sixth term is 27, equals 27, right? When you plug a 6 in, it is 27. Okay, so that's one of them. And then I do the same thing again. A1 plus, the D. This time, what's the D? 15th. 15th is negative 63. Is that good how I have these two equations now that have A1 and D? Two equations with two unknowns. See how I just plugged in twice to the A sub n formula? Remember doing that? Coming back now? So then, what can we do? We can say, okay, A1 plus 5D is 27, and A1 plus 14D is minus 63. Like that. Is that good? And then, what's the easiest way to solve these? Do you remember? Yeah, just multiply through by -1. Like I could do the top equation or the bottom, doesn't matter. Let's make that negative, negative, negative. So I just multiplied through by -1 on that top equation. And now I can add them because A1 minus A1 will cancel out. That'll get rid of one of the letters, huh? Bless you. Everybody see what he did there? A1 minus A1. And then 14 minus 5D, what's that? 9D. What's that? Minus 90. We get you there. Divide by that. D's minus 10. So we got our hands on D. Okay, so now how do we get A1? We'll bring it up here. And just plug into any equation you want. Like I'll just grab the first one. A1 plus 5D is 27. That was the first one before I put the negatives through it, You could do the negative version, doesn't matter. So plug in D is negative 10. So A1 minus 50 is 27, right? And then add 50. A1, was that 77? So we got it. A1 77, D is minus 10. Two equations with two letters, is that okay? Questions I can answer?
So if you plug it into the second equation, you would also get 77?
Yeah. Did you? I could do it real quick.
What are you running?
Yeah, it's just easy to make a small mistake, but you should. So you mean you plugged into this right here, the A1 plus 14D? A1 plus 14D is... It's easy just to drop a minus sign or something. Let me see. So what's D is negative 10. It's negative 10, right? Like that. A1 minus 140. So we should add 140.
Oh, I see what I did.
Yeah, easy to make something small happen. Okay, good. Found it? Okay, yeah. So it should be the same either one. Good. Other questions on that one? All's well. All right. Let's keep. All right. So, yeah. This I will keep this here. A summation formula must be used. Steps shown. Just using graphing calculator won't get you any points. Notice, I know some people in pre-calc always learn how to use their graphing calculator to just enter a summation. That's great. I mean, I would do that too if I were you. Do that, hit the buttons, get your answer, and so you know what the answer should be, but then you got to show me the formula usage as well. So if you learn how to do that in your calculator, excellent. If you haven't, if you have time, time's always a crucial thing. None of us have enough time, it feels like. But if you had a little extra time, go online or whatever, come by my office, I'd be glad to work on it again. Figure out how to, your graphing calculator can just crank out the answer automatically. There's a way to, it does summations, you know. If you've already got that, great, and you can just do that quick, write down the answer, but you do, to get the points, it's great to do that. That way you can double check, you know, your formula work. But you have to also show me the formula work. So let's do the formula work. So, yeah, it doesn't say if it's arithmetic or geometric, does it? So that's, what's that? Well, we have two S sub n formulas, right? It is definitely going to be an S sub n because that is a big Greek S. So it's a sum. So remember, we have a sum formula for arithmetic and a sum formula for geometric. We have two S sub n's. So how are we going to figure out which one it is? We just got to crank out a couple of terms and see if it's adding the same number every time or multiplying. You know what I mean? Like if I find out the first term is a 2 and the next one is a 6 and the one after that's a 10, I'm going to go, oh, it's adding 4 every time. It's arithmetic. But if I find out the first one's 2, the next one's 6, the next one's 18, I'm going to go, oh, it's timesing by 3 every time. It's geometric. You know what I mean? I just have to get the first 3 terms and then I'll know, is it arithmetic or geometric? And then I can go grab the right S sub n formula because there's one for each. Right? One for arithmetic, one for geometric. So let's go find the first 3 terms. That should be all we need. So, all right. So what's a sub 1? What's a sub 2? What's a sub 3? So how do you find a sub 1? Well, you just plug in k as 1, and this will be plugging in k as 2. This will be plugging in k as 3, right? We're into that formula right there. So 1/4 times minus 3 to the 1 minus 1, and this will be 1/4 minus 3 to the 2 minus 1, and 1/4 minus 3 to the 3 minus 1. We good to there so far? I'm just plugging in k equals 1, and k equals 2, and k equals 3. And this is just 1/4, because anything to the 0 power is just 1. And this is going to be minus 3/4. Is that okay? That minus 3 just goes to the top, right? When a whole number interacts with a fraction, you just put it over 1. Remember all that kind of stuff? Are we okay with that? And then the last one, 1/4 minus 3 squared. What's that? 1/4 times 9, that's 9/4. Right, again, the 9 is over 1 and goes to the top. We good so far? We okay? Trying to read your faces, I'm getting nothing. Are you happy so far? Questions I can answer? Is it confusing? What I'm doing, is that making sense? Plugging in k equals 1, k equals 2, k equals 3 to find the first 3 terms. And now what I'm trying to do with that is figure out if it's, what's happening? Like, how does 1/4 become minus 3/4? And then, like, what's the one thing that's happening? Is it adding the same number every time, or is it multiplying the same number every time? Yeah, it's multiplying. And what number? Notice the 4 is a fixture. He's not changing, right? So don't let that throw you off. When you compare 1/4 to 3/4, the only change is the 1 on the top has become a minus 3 on the top, and then it's become a plus 9 on the top. Huh? So the change is just happening in the top. So don't worry about the 4 on the bottom. That's just a permanent fixture. So what's being done on the top? It's timesing by -3. Exactly. So everybody see that? Times -3, then times -3. That'll make -3 times -3, positive 9. Yeah, that's exactly what's happening, right? It's just multiplying by -3 every time. So is this an arithmetic or geometric? It's geometric. It's geometric. So geometric. It's times by -3. It's multiply -3 each step. And that, in fact, is my R. If you're not sure, remember R can always be found R is the second term over the first. It is negative 3, but just to double verify. Second term over first. Minus 3/4 over 1/4, flip it up. Minus 3/4 times 4 over 1/4 cancel. See, there it is, minus 3, as we already knew. R is the minus 3. It's the ratio. Remember how to find the ratio, the R in a geometric? Second term over first. Everybody see what I did there? So the R is indeed negative 3. But you could tell right here, so you didn't have to redo it if you were comfortable with that first bit of work. All right, so can I erase some of this stuff now, and we'll go ahead and get now we know which formula to grab. So these are a little bit of work. Which formula to grab. So we're going to grab it's not A sub n, it's the S sub n, because this is the Greek S, right? That's a Greek S. So we're summing them up, we're adding them up. It is, I can never remember it. What is it?
First term times 1 minus the ratio.
No, isn't that the A sub n? It's
That's to sum of geometric sequence, right?
sum.
First times 1 minus the ratio to the n power.
Oh, you're right, Robert. 1 minus R to the n over 1 minus R, like that? Yeah, thank you. Good. All right, so there it is. And so A1, the first term. What's the first term?
1/4.
That's that 1/4. And what's the R? That's the negative 3. That's our R here. So careful of the signs there. Get the subtraction and the negative 3 to the n power. Do we know what n is? What is n in all these formulas always? Number of terms. N equals number of terms. How many terms are there? 13, huh? N equals 13. Because you're going from 1 to 13. So this is when I say to receive the full credit, you got to show me this. And at this point, if you could just hit the buttons on your calculator and get the answer, or if you already did with the special summation, great, I'm happy. As long as I've seen the formula, seen the R plugged in and the A1, then if you could just jump right to an answer now, that's fine with me. I'll show a couple more steps if that's helpful. So this bottom 1 minus 8 is going to actually be 4, huh? Because it'll add there. The top will actually be 1 plus 3 to the 13th, won't it? Have to be a little careful there. You can't just automatically cancel those negatives, although it kind of looks like I did. Really, I looked at this and said, look, odd power on a negative. It's going to be negative. With another negative, it's going to be positive. You guys with me on that? If that had been a 12th power, because the power must be done first. You can't cancel those two minuses in the middle first. You've got to first do the power, don't you? And if the power had been 12, it's not 12. But just do a what if for a second here. If that power had been 12, then the negative 3 to the 12th would be a positive. Then I would have minus in the middle here, wouldn't I? Because the subtraction symbol would remain in that case. But it's odd, so the negative 3 to the 13th power is negative, hits the other negative, positive in the middle. So this is what? 1/16, 4 times 4, times 1 plus 3 to the 13th. Hit the buttons. At that point, it's hit the buttons, right? You can hit the buttons at any stage that's not hard for you to hit the buttons, whenever you want. I'm just trying to make it a little easier so the button pushing isn't so hard. But whatever point you need, jump in, hit the buttons. So somebody got an answer there?
99645 over 4.
2 decimals. One more time, sorry?
99,645 over 4.
Oh, over 4, you got to be a big fraction? Yeah, I did say 2 decimal. Somebody got that in a decimal?
0.25.
What is it?
0.25.
Well, I mean like the whole number.
It's over 4. 0.25.
99645.
Oh, 99645.25. So it's not really this. I didn't write. That's not what you meant. Okay. So it's just this? That's it?
Yeah.
Great. Sounds good. Is everybody good with that? Question? You have trouble with getting the calculator to go there? Come see me. I better move on. We spent a lot of time on it. Okay, look at that. Solve the system of equations 3 by 3 by hand. by hand, show your work. That was back when I used to be a meme teacher, and now I'm so easy, not easy, but I'm not going to do this by hand. Remember I said you could use your calculator on the 3x3s? I just want to let you know, I'm getting old and soft, I guess. So I'm not really, I don't think I'm soft. I think I'm holding a faithful standard. I think you'll be ready for calculus, having done well in this class. But anyway, I don't think it's necessary to do all that work. So I'm not going to say you have to do it, by hand. Calculator is okay. Just use your graph calculator. What do I mean? Let me show you real quick. You just peel off the numbers, right? The 1, 1, 1, so 1, 1, 1. And just stick the -8 in there also. 1, -1, 1, -1, 4, 5, and 2, what's that? 1, 1, -12. Just stick that in there. Put that in matrix A or whatever in your calculator, and then hit RREF of matrix A. Enter. Remember how that all works? You guys remember you put this in your calculator, store in matrix A. You store that in matrix A. The whole thing. It's called an augmented matrix. Has the answers at the back as well, I mean the equation answers, not the overall final answer. Anyway, and then to get to RREF, where is that? That's under the, what do you got to hit? What are the buttons again? You got to hit second matrix, right? And then, go across to, what's it called? Math or calculate or?
I think it's it might be math.
I forget. Can I check your time?
The one if you said
It was under math.
Oh, it's under math. Yeah, it's names, math, and ed. It's under math. Yeah, it's under math. Yeah. So go across to the math menu and then go down to RREF. Hit enter. So RREF's on your screen, and then you got to go back and hit second. See, this is step 1. Well, this is really step 1, is store that in your calculator. Then go to REF, and then step 3. Let's go back to second matrix again. Go under names. You're already under names. Just hit enter for matrix A, and then hit enter one more time. Enter twice, and it'll do it. Somebody got an answer? Got the 3? It should be X, Y, Z. 3 answers? X equals, Y equals. Am I going too quick? -4, -5, and +1? Good. Sounds like a couple people got that. There it is. So make sure you can do that on your graphing calculator. It'll be a lot easier than doing anything by hand. You don't want to waste all kinds of time doing those by hand. You'll have my respect. How about that? That good? All right, I'm going to... all right, so this one, see the ... What does that mean? They're added up at a ... So which formula are we going to use? Even says it here. S sub infinity. Right, it's the infinity formula, which is again at the top of your paper, top of your test. You don't even have to put my 3x5 card, they're all up there. The S sub infinity formula, because it's ... and even says infinite, geometric. Okay, A1, 32, it's always the first term, right? 1 minus, now what's R? R is always second term over first. So R is 32 over 8. And more time here. It's 8 over 32. You could just use a decimal if you want, 0.25 or 1/4, whatever you want. Decimals are fine with me, probably easier. 0.25. I don't care. Decimal answer is good as a fraction to me on the test. Second to there. Everybody okay with that so far? Oh, remember there was a test. We had to make sure that the R is between -1 and +1. And so 0.25, yes, it's okay to use the formula. If R is not between -1 and +1, then you say it diverges. Remember that whole business? Right, you have to check the R when you do the S sub infinity formula. You have to make sure the R, which came out to be 25 cents, 0.25, is between -1 and +1. It is, so it's okay to use the formula. If the R is not between -1 and +1, then you just say diverges.
So diverges is another way of saying infinite, right?
Not necessarily.
I mean, it will go
In other words, you can have like the sine curve.
right?
The sine curve goes up and down between and never actually lands at a certain height. So it doesn't go to infinity, but it also doesn't converge. It doesn't arrive at one height. So it can mean that also. You're right, usually they take off to infinity or negative infinity. But diverges technically means it doesn't converge. It doesn't come to one settled value. It just goes up and down or takes off or what means something like that. It doesn't level off ever, is what you're saying. But this one does, because the R value is between -1 and +1. You get all into that in right in the beginning of Calculus Math 5A. You'll talk about convergence and divergence and all that. So anyway, I don't know what that is, some decimal thing. Whatever your calculator says. I want to move on. Is that good for that one?
That's tied to like the when they say find the limit of the.
Yeah, it's limits. Exactly. Yeah. And when they diverge, you say it doesn't have a limit.
Yeah, so in other words, the limit doesn't exist.
Doesn't exist. Yeah, I know you always jump ahead on your next class, Robert. So yeah, that's chapter 2 in the book. When I start looking at it, that's when they say the limit doesn't exist. D and E does not exist when it diverges, right? All right, let's take a look at that one. That one is, we got it's going to be an S sub n. Oh, look at the time. We're out of time, aren't we? I can't believe it. This one, you would just use your graphing calculator again, do RREF, like we just did. This one is S sub n for arithmetic, right? Because it's the Greek S. You know it's arithmetic because this is linear. That's the other. Yeah, remember how I showed you if it's linear, you know it's arithmetic, and if it's exponential, it's geometric. Remember that?